Okay, good evening, everyone. All right. So sorry we could not upload the remaining videos of yesterday's physics class. Okay, so we're going to do that today. All right. So we were talking about motion, and we're talking about um, the quantities that revolve around motion. So we looked at displacement, we looked at distance, velocity, and time. Now, additional information. This is talking about speed. Like I said yesterday, speed is a scalar quantity. The velocity is a vector quantity. So we said the SI unit of speed is meter per second. All right. So most times we'll be given in kilometers per hour. Please take note. Once you are given your speed or velocity in kilometer per hour, you need to convert it to meter per second. So how do you convert from kilometer per hour to meter per second? Just multiply what you are given in kilometer per hour times 1000, divide the resulting answer by 3600. Okay, then you get your answer in meter per second. So we say it is a scalar quantity. It is the slope of a straight line distance time graph. Now listen, this is a key jam question that comes out. Take note. They can ask you the slope of a distance time graph is called what? The answer is speed. The slope of a displacement time graph is called displacement. Take note of the two. Sorry, velocity. The slope of a distance time graph is called speed, while the slope of a displacement time graph is called velocity. Now you can be asking another question that comes up in JAM is this. The area under a velocity time graph is called what? The area under a velocity time graph is called what? The answer is not acceleration, because most people would think that they're asking for velocity over time, which is acceleration. No. The area under a velocity time graph is called distance covered. The area is called the distance covered. Don't you be asked to find the area of the trapezium formed from the velocity time graph. So the area is called the total distance covered or the distance covered. Now look at the examples. Example 1, calculate the speed of a car when it covered the distance of 8 meters in 4 seconds. These are preliminary examples. I just want to take us through the preliminary stages before we go into the complex stages. We're going to end that part of motion tonight. Then our next class will move quickly to motion under gravity and projectiles. All right. So we have the distance to be 8 meters and the time 4 seconds. So the notes are very, very explanatory. So we use our formula for speed, or the one we use in the primary school level: average speed, distance over time taken. So distance is 8, time is 4. You get you do your division, and you have 2 meters per second. Number 2, how far would a body move in 12 seconds if its speed is 3 meters per second? So we are looking for distance. Distance is given as what? Speed times time. Your speed multiplied by your time, which is 3 times 12, you get 36 meters. Next, we have velocity now. Velocity. We have velocity. Now, for velocity, we have two types of velocity. We have the initial velocity, we have the final velocity. So the initial velocity is simply the velocity of a body, either at rest or when it's about to move. The velocity a body possesses when it's about to move or when it's at rest. While the final velocity is the velocity a body possesses when it comes to rest. Now for acceleration, I told you that another quantity that's governing motion is called acceleration. What is acceleration? Is the rate of change of velocity. The rate of change of velocity, or the change of velocity with respect to time. So velocity change is given at final velocity minus initial velocity over time taken. You have the formula there. Your v is the final velocity. Very well explained, very crafted out. Now, so we have acceleration, all right? So now the SI unit of acceleration is meter per second. I'm just taking these preliminary stages for most of us that have forgotten them, or most of us that it's been long we opened our books, all right, so that we can have a foundation to lay other topics upon. Now, all right, look at the question. A car accelerates uniformly at the rate of 5 meters per second square. Calculate the velocity after 3 seconds if its initial velocity is 2 meters per second. Now, this formula for acceleration, A equals to V minus U over T, is also one of the equations of motion. One of the equations of motion. Now, we have the acceleration 5 meters per second square. We have the velocity Okay, calculate its velocity after 3 seconds. That's the final velocity. We have the time to be 3 seconds, and then its initial velocity is 2 meters per second. All right. So from the steps below, you have A equal to V minus U over T. If you make V the subject of the formula, you're going to have V equals to U plus AT. U plus AT. Your U is 2 meters per second plus your AT 5 times 3, that's 15. So when you have 2 plus 15, you have 17 meters per second. So you can try the other question out. Calculate the time taken by a car to change its velocity from 8 meters per second to 20 meters per second if its acceleration is 4 meters per second square. Okay, now, so we see the solution there. You can try it out yourself. All right, now we have average speed. Average speed, all right? Average speed. What's average speed? Simply is the time rate of the total distance covered. The time rate of the total distance covered. So, see the difference between speed and average speed. Speed is just normal distance over time. Average speed is total distance covered over total time taken. All right, some key areas that bring out is what I call uniform speed, uniform acceleration. Uniform speed, uniform acceleration. The notes are self-explanatory, quite very very explanatory, because um I coined them from one of the best textbooks for JAMB, post JAMB, and YX students. So they are very very self-explanatory. Now, what is uniform speed? Something is uniform. We are saying um the uh the rate of increase in the distance and time are equal. That's uniform, uniformity, equality. The same thing with uniform acceleration. The rate of increase of the velocity of a body per time is also what? Equal. All right. Now, the same thing with uniform deceleration. These are the basics. All these form the equations of motion. We have basically three equations of motion. The fourth one, we use it once in a while. The first, which is S equals to V plus U over 2 times T. You can take it down. The second one, V equals to U plus AT. The third one, V square equals to U square plus 2AS. And the fourth one, S equals to UT plus half AT square. Your V is your final velocity. Your U is your initial velocity. Your T is your time taken. Your A is your acceleration. And your S is the displacement or distance covered. Now, how do we use the equations of motion? Very, very simple. You'll be given the question. Write out the parameters you are given in the question. You'll be given at least 3 parameters. 2 visible one and most times 1 invisible one. In the sense that the question may come, a body accelerates uniformly from rest. Once you hear the word from rest, that should bring to your mind that the initial velocity of the body is 0. So you'll be given 2 other parameters in addition to the initial velocity, which is 0. Then you'll be asked to find the 4th parameter. So how do you know the equation to use? Just check which of your equations carry the 4 parameters given to you in your question. 3 given parameters and 1 parameters you are asked to look for. Once you get the right equation, you apply and solve. That is just what equation of motion is all about. So that is just all on motion and equation of motion. You can try out these questions. I have a lot of questions, but the essay questions, not really bother much about them. Our focus is on the objective questions. Now we have the slope objective questions. For the slope of a straight line displacement graph. Okay, the slope of a straight line displacement time graph indicates what? I said it before. Distance, the slope of a distance time graph indicates speed, distance over time, speed, while the slope of a displacement time graph indicates the what? Velocity. So what should be the answer? You should know the answer from there. So you can pick your answer from there. Now this is a continuation of the question. Okay, so this is a continuation of the question number 2. The speed of an object in rectilinear motion can be. All right, so we have all these questions, so we can drop the answers on the platform, or you send it to me, then I'll send the correction so that we can check. These 95% of the questions I have here are jam questions. Are jam questions on motions and equations of motion. So this is what we're going to stop on motion and equations of motion. Our next class we enter motion under gravity and projectiles. What the last class will take, because motion covers most areas in physics past questions. And the last part will take on simple harmonic motion and will take on wave motion. They will now touch a bit of light and optics. All right. So thank you very much for your time.